Hello, everyone. Just going to do another update here. So we do have a couple of changes. I'm not entirely sure that I buy some of them, but the models have the storm a little further east today, contrary to what I thought yesterday. I'm just going to quickly go through the 500 millibar vorticity, and sorry for any background noise. So this is the 18Z GFS from today. And I just want you to focus on the shortwave trough here, its position and its orientation. So here, in today's run, we noticed that um, between this run and then yesterday's run, first off, in yesterday's run, the trough is further south, so it digs further south if you notice that. And it's also further to the west. So here it's slightly further north, and it's also further east, um, further east here. So that's a little interesting because with it further west yesterday, there's more room for the southern stream energy to come up the coast rather than out to sea. And the trough is already starting to go negative if you see from northwest to southeast. And then in today's run, by the way, this is late Friday night. The trough is north to south, so it's neutral and it's further north and it's further east. So all of these things are pushing the southern stream energy further out to sea. But I think another thing that's happening is because when I look at the surface map, I see that the storm is actually stronger and slower in the newer run at the GFS. Normally, when you have a stronger, slower storm, it comes further west. So that's why I'm still convinced that this can come further west. But I think the fact that this is further to the east is actually allowing all the energy to consolidate a little quicker, and that's making for a stronger storm. But the tilt of the trough and the fact that it's moving quicker and the fact that it's not as far south as the trough here. Again, it's not that much of a difference, but it makes a difference when you really think about it. So then you go forward in the run from yesterday, and you go forward in the run here. So there's not much of a difference, but if you look really closely at the trough here, yesterday, notice that it's further to the west and more negatively tilted. You can see that, not by much, but it makes a difference. So you see the southern stream energy is closer to the coast and not consolidated yet. But over here, you see that the southern stream energy is just slightly further east and it's not as close to the coast, whereas the overall trough is further to the north and east than on the old run, where it's further south and west and slightly more negatively tilted. So if the trough is moving faster and it's not tilted in such a way and it's not as far south when it digs, storms typically go out to sea as opposed to coming on shore on the coast. But so let's go forward. This is yesterday's run, and you see going into Saturday night, the low has yet to close off, and it looks like all the energy is further to the west. And if you go into today's run, the low closes off like Saturday night, and we know that in the old run that I showed yesterday, it doesn't close off till it gets to Maine. So I think because the trough is going faster to the east, it's combining with the southern stream energy quicker, but because it's not as negatively tilted and it's not digging as far south and it's moving quicker, I think that's why even though we have a stronger storm, it's getting pushed further to the east rather than coming back west. So the the idea here is that the trend has been for it to come further west since late this weekend, and that trend had been pretty consistent. But now, and not just the GFS, but the NAM, and I haven't looked at the European model, but I know the NAM and I think some of the ensembles are still farther to the east with the storm. My friend told me the ensembles have actually been coming further west, but I've noticed that in the more recent runs of the GFS and especially in the NAM, which are the two main deterministic models I look at since I'm not registered to look at the European model data, they're mainly further to the east. So typically when a new trend starts 2 to 3 days out, from a storm, that trend tends to stick, I think, in my opinion. Although I have seen some cases where there is a trend that develops 2 or 3 days out and then reverses the day of. I have seen that. I don't see it that often, but I have seen that happen before. Or it's something that the forecasters just miss the day of, and I'm guilty of that too. So I think this storm can still come back further west. I don't think the differences I pointed out are that major. They're more on more on the minor side. The digging further south, it's just by about 50 or 100 miles, and then the tilt of the trough isn't off by much too. The major difference is the speed of the trough. The speed of the trough in the new run is a lot quicker, and those lead to more progressive systems that tend to just affect a small area and go out to sea. But the strength of the storm is what really gets me, because usually when you have a very strong storm like that, and I'll show you on the surface map, I'm just going to go back here. Typically, when you have a very strong storm, it will come further west and move slower, but that's not the case here. But notice we're at, I can't even read that number, 986. Remember, yesterday it was at 975 over here off of Cape Cod on yesterday's GFS run. And if you go to today, it's at 956. That's a big difference. And most of the models are showing a very intense storm off the coast here. So I just feel like this can come further west still. The speed of the trough might be the nail in the coffin here. I think if the trough moves too quick, it will go out to sea. But I'm not ready to give up on a coastal storm just yet. So, because of that, I am keeping my threat area like this. I'm not changing it. It's too early for me to give up on this yet. I still think it has room to come further west. So, this threat area that I went over yesterday is not going to change yet. If the eastward trend continues tomorrow, um, which it could, but I still I still think that it could come further west. So if the eastward trend continues, though, I will start to shave this down a little bit and maybe say that it's immediate coastal areas that are at the highest threat for heavy snow, which is how it looks now based on today's model runs. So anywhere coastal Maine, coastal I think that's New Hampshire, if I'm correct. Don't get my geography mixed up. I'm sorry. Coastal Massachusetts, maybe going back inland to central Massachusetts, Rhode Island, central Connecticut. And then at this point in time, I would have to put New York City on the western end of the threat. Philly, I just based on what I'm seeing, not your storm. And then coastal Delaware, maybe. And then maybe going back into coastal Virginia. But so this would be what I'm pointing out right now, my greatest potential right now for heavy snow. But I am not ruling out that this can come further west and bring snow all the way back into eastern Pennsylvania and the lower Hudson Valley up into the Catskills and even past that. I'm not ruling that out at this point in time. So that's today's update, and I will be back tomorrow.